Right, good morning everyone and welcome to our webinar which is entitled Rewriting the Resource Rulebook. During this session we will be examining how to maximise the potential for waste as an energy resource. My name is Maxine Perella and I head up ED's Waste Channel. I'm joined by Rolf Stein, the Chief Executive of Advanced Plasma Power, which is a leading advanced conversion waste to energy technology provider. I will ask Rolf to briefly introduce himself in a moment, but first I just want to set out the format for this morning's agenda. The first part of the webinar will look at the current regulatory and economic drivers around energy from waste, the opportunities and challenges these pose, and how advanced treatment technologies can help meet the government's zero waste and renewable energy targets. The second part will then look more closely at how waste as a resource and energy source can be maximised using a particular technology, and this will be led by Rolf. We will then open it up to questions at the end, and I do encourage you to send through your questions at any point during the webinar. Please note that once the webinar has ended, you won't actually be able to ask anything. So do raise any points or issues you have while we're talking. The way to do this is on your screen you will see an Ask Question button. So press that, type in your question and submit it to us. We will also be running 2 polls during this webinar which you can vote on, and we will be activating these during our discussion. So Rolf, if you could firstly give a brief introduction, who you are and what you do.
Certainly, thank you, Maxine. My name is Rolf Stein. I'm CEO of Advanced Plasma Power, the leading UK-based waste-to-energy technology company. We have developed the gas plasma process that utilises existing and proven technology in an innovative application to process refuse-derived fuel to produce an energy-rich gas for efficient energy and heat generation.
Great, thanks for that. Okay, so if we can kind of kick off the discussion, let's consider the political climate right now. We have a number of key drivers. We have the government's waste review, which has zero waste as its aim, set against the European Commission's call for higher priority to be given to reuse and recycling under the waste hierarchy. Now, there does seem to be a policy shift occurring towards waste prevention and extracting more value from secondary materials. So where does this leave energy recovery, Rolf, given its lower priority down the resource management chain?
I think given our ever declining natural resources, it certainly nearly always makes economic and environmental sense to drive as much reuse and recycling as possible. Energy recovery processes and technologies which embrace, therefore, the shift from waste to resource management and which are complementary to recycling certainly do exist and should prevail. It makes little sense, for instance, to introduce inorganic or non-calorific materials into an energy recovery process. Firstly, these materials, such as metals or glass, for instance, have a value as a recyclate, and secondly, they themselves have no energy content. Recycling and energy from waste are therefore by no means mutually exclusive. Many processes, such as our own, remove recyclates in a materials recycling facility at the front end in order to produce an energy-rich refuse-derived fuel. This in itself is a resource which should be converted into energy in the most efficient way possible through advanced conversion processes. These processes also often produce a vitrified product from any residual ash content of the RDF, which product in itself is a recyclate with a variety of end uses. As such, they achieve almost complete landfill diversion.
Yeah, it's an interesting one, isn't it? Some believe out there certainly that there is a conflict between energy and waste, in that if you start to focus on maximising energy recovery, well, these energy from waste plants are hungry beasts, and it could start to have a detrimental impact on recycling rates. We're already seeing a rise in export demand here in the UK for refuse-derived fuels to Europe, for instance, where facilities are running out of feedstock. So would you agree with that, Rolf? Do you see potential problems ahead? Or do you feel there's sufficient room for both approaches to work alongside each other in harmony, where we can extract the extra value needed from recyclates and still leave enough in the residual stream for generating the amount of renewable energy that we need?
I think that energy from waste and recycling are certainly by no means mutually exclusive. They can and do work alongside one another for the reasons already mentioned. In the UK, for instance, currently we produce some 90 million tonnes per year of residual waste, of which around 45% or so is recycled. Around 40 million tonnes per annum, therefore, currently goes to landfill. Even if we were to achieve the sort of symbolic 50% recycling rate, or even 60, which certainly many consider to be pretty challenging through source segregation and conventional means, there would still be a need to divert some 30 million tonnes or so per year of residual waste from landfill. This stream will still contain recyclates, which should be removed during the preparation of an RDF, thereby boosting recycling rates. Furthermore, we could be mining our existing 2 billion tonnes or so of landfill for valuable resources and fuel, as we are doing, for instance, on a pioneering project in Belgium. Instead of sending the RDF abroad, we should be using it in the face of our emerging power gap in the UK to generate more renewable energy and to produce secure and sustainable power in the UK.
Okay, great. Thanks for that, Rolf. It'd be great to get some audience feedback on this particular issue, as I know feelings can run high on this subject. So I'm now going to activate our first poll, and you should see this flash up on your screen now. And the question it asks is, energy from waste, can it sit comfortably alongside the recovery of secondary materials? So please vote on this, and I will announce the results a bit later on. So let's look at renewable energy, and let's look at how much renewable energy is required. It does look pretty challenging. We've got the EU's Renewable Energy Directive, which requires the UK to source 15% of its energy from renewable sources by 2020, and already it seems like we're running into problems in terms of where we can source this energy from. Our current rate of growth of renewable energy in the UK is too slow at the moment. So to me, it seems there's a definite opportunity there for energy from waste. Now, according to the CBI, energy from waste currently accounts for 1.5% of the UK's total electricity requirements, which is about the same as that generated by wind. Now, the CBI reckons you could easily quadruple that amount to 6% by 2015. It's just really a matter of getting the infrastructure off the ground, which obviously requires investor confidence, a less cumbersome planning process, and of course community buy-in, which is essential in terms of feeding into that. Some would say it seems a no-brainer, but Rolf, do you feel there's enough of a sense of urgency out there to make this happen? And should the government be doing more to encourage the right market conditions?
We certainly see a significant opportunity for energy from waste in the UK, and in particular for advanced conversion technologies, which really sit at the interface or convergence of all the diverse regulatory drivers in respect of recycling, landfill diversion, efficient energy generation, heat recovery, and also local acceptability under the localism agenda. We ourselves are developing a strong pipeline of projects which would contribute significantly to the UK power mix. I think the CBI numbers are probably conservative in terms of what could actually be achieved, and others put the contribution at considerably higher, certainly by 2020. Obviously, the rate of rollout is dependent to a significant degree on the right economic factors, as you mentioned, and at a time of a liquidity squeeze, other investors are certainly being attracted into the sector. Pivotal, I think, to achieving the right level of return for those investors, and therefore to the rollout, is the support provided under the RO, the Renewable Obligation, and in future, of course, the feed-in tariff and contract for difference regime.
Yes, I mean, let's look at the Renewables Obligation certificates, the ROCs, in more detail. DEC has recently proposed to halve the level of subsidy available to conventional energy from waste facilities under the Renewables Obligation from 2013. So currently at the moment, operators using EFW with combined heat and power technology can claim 1 ROC for every megawatt hour of electricity generated. Those using advanced conversion technologies such as gasification or pyrolysis can currently claim 2 ROCs. But again, this level of subsidy will decrease under DEC's proposals. So what effect, Rolf, do you think this will have on the long-term viability of energy from waste as a mainstream treatment technology if the ROC subsidy is halved or, well, even removed altogether?
I think ROCs or their equivalent are clearly essential for attracting rapid investment into the sector to ensure that energy from waste becomes the significant contributor to the UK power mix, which it ought to be. It is always right, however, in my opinion, to offer the greatest support to the most efficient, most sustainable, versatile and deployable solutions, especially at a time when many of these are at the cusp of adoption. It will therefore come, I think, as no surprise to you or to the listeners that we support DEC's recently published proposals, and we will, of course, be informing the consultation process. We ourselves benefit under the proposal, under both the current regime and under the proposals, benefit from 2 ROCs. As to what the right levels of support are for all the different approaches, I think it's difficult to comment without reviewing and understanding all the data, which in itself has gaps. Clearly, there is a call for evidence to plug some of those gaps to the industry, and the levels will obviously be set having regard to that evidence.
Great, yes, I guess it's a case of wait and see, really, on that front. Okay, to wrap this discussion up, really, I'd like to ask one more question. It's quite an interesting one, really. I learnt recently that RAP are now in talks with DEFRA to draw up guidance on energy from waste, which will be released sometime, I think, in the new year. I suppose the big question here really is whether the government will take a particular direction on a preferred recovery route, or if they will remain technology neutral. So, Rolf, if you had one message that you could give to ministers right now, or indeed any policy influencers that might be listening in, on what this guidance should aspire towards, what would it be?
I think obviously you'd expect me to make the case and argue the case for advanced gasification and for our technology, gas plasma in particular. And I will certainly seek to do this, in the subsequent presentation slides. However, I think the argument is relatively straightforward. Government, whether locally, centrally, or at European level, has set certain policy objectives and implemented mechanisms to drive behaviour in line with those objectives. In my view, a joined-up approach needs to be taken. A view needs to be taken of all the technologies and processes which tick all of the policy boxes. So the processes which are complementary to recycling, maximise energy efficiency, maximise landfill diversion, and offer the best potential for heat recovery and CHP, whilst also having a low environmental impact both visually and from an emissions perspective, and thus being perhaps more locally acceptable, are I think those that it stands to reason should be preferred, and that the policy should come together in that regard. Perhaps I may make a second point, which I think is an equally important message, that whilst policy consolidation and guidance around a particular approach in line with what I've just set out may certainly be good, I think sudden change is inevitably bad. So a route map which sets out now what the policy objectives are going forward and should be adhered to, I think would certainly renew investor confidence in the sector.
Okay, that's great. Thanks for that. It's certainly been very insightful. Now, we've had quite a few votes on our first poll. So I'm just going to read out the results, and wow, it's an overwhelming 89% of you do believe energy from waste can sit comfortably alongside the recovery of secondary materials. 11% aren't sure, but actually nobody said that it couldn't. So I guess that's good news, isn't it, Rolf?
It is. I think that's it is certainly what we would expect to be the correct view.
Okay. Now what I'm going to do is activate our second poll before we go into the second part of the webinar. And this one is asking, what is the biggest barrier to greater uptake of EFW technologies? And there are a few options there, so please choose the one you feel really is of most concern. And also, just to remind you, if you do have any questions relating to our discussion or for the second part of the webinar, please do send them in. Remember, we can only take questions that are submitted during this live session. We'll be having a Q&A session at the end, and we'd certainly like to hear your thoughts. So we're now going to move on to the second part of our webinar, and here I'm going to hand over to Rolf, who will talk in more detail about the benefits of one particular treatment technology. Over to you, Rolf.
Maxine. Thank you. So I really wanted to give a brief introduction to APP and its gas plasma process. The company was established in 2005, having been spun out of Tektronix, which I'll talk about a little bit in a second, with the purpose of developing and commercializing the globally patented gas plasma energy from waste technology. We moved to premises in Swindon in 2007 and installed the plant in that year, which has been operating since 2008. We're funded to develop our own pipeline of projects, which are particularly in the UK through to financial close, and have now a requirement for significant project funding to close projects during next year and the following year, and of course beyond. Just briefly on Tektronix, it is a leader in DC plasma arc technology, having been established around 50 years ago and supplied some 80 systems globally in a variety of different applications. It has an extremely strong and mature IP portfolio and team of both technical and commercial staff. Plasma technologies, I will come on to explain, is obviously a key component in the gas plasma process, and Tektronix are our supplier for that component. The areas of application that the company has focused on historically, obviously waste to energy being the gas plasma application, but for many decades the vitrification of incinerator residues, both bottom ash and APC, air pollution control residues, or fly ash, particularly in Japan, which were early adopters of thermal technology, but also have preferred to vitrify the incinerator waste, thus stabilizing it, etc. Tektronix has also worked for many years with NDA and site license companies on vitrifying low and intermediate level nuclear waste, again to stabilize it, make it chemically inert, but also to reduce the volume of the arisings so as to make the material suitable for long-term storage. And other industrial applications range really from very problematic waste such as spent pot liner and organic pollutants, which themselves have an energy content, and where energy is recovered typically in the form of steam to recycle back into those industrial processes, but also base metal recovery, so for instance residues from stainless steel plants containing zinc and nickel and chrome and other heavy metals, to recover those metals as a valuable resource. And also precious metal recovery systems, or platinum group metal recovery systems from, for instance, spent auto catalysts or industrial catalysts. The size of these systems range according to the application, but certainly up to 30 to 50,000 tonnes per year of material. Many references exist. So really, in the context of what we discussed earlier, APP and the gas plasma process really aims to address two global challenges. One is what to do with our problem globally of rising residual waste, whilst landfill capacity is in decline and our natural resources are in decline. As already said, we embrace the shift from waste to resource management, seeing waste as a source of valuable resources, both in material sense, but also in a fuel sense. Secondly, we seek to address the challenge of generating more secure energy, renewable, sustainable energy, addressing the requirements, the need to address climate change, obviously, and low carbon generation. We are a baseload generator as opposed to an intermittent generator, therefore are not dependent on the elements in any way, and at a cost really which is affordable both in capital and legacy terms. And estimates put the contribution which energy from waste can make by 2020 at roughly the same sort of level as nuclear, but come online far more rapidly. Just to really set out the problem that is looming in terms of energy security, as our existing capacity goes offline, particularly coal stations go offline, there is a looming shortfall in energy generation capacity in the country, and clearly we need to address this urgently. Conventional energy from waste processes typically combust waste, residual waste, without any pre-sorting, and heat water to raise steam, to drive a steam turbine to generate electricity inefficiently. And this has inherent efficiency limitations. The processes produce a high volume of residual ash requiring treatment or disposal. There are certainly in the public eye concerns over emissions. The systems typically have quite a significant visual impact, being very large buildings, some 35 meters or so in height, with large stacks, again some sort of 70 meters or so in height. And in the main, I think it's fair to say that the conventional processes generally lack public support. So how are we different? I think it's summarised quite neatly by Fichtner, the leading consulting engineers who have undertaken extensive review and validation of our process. For many years, developers have been seeking ways of generating a gas from waste which could be used to power gas engines or turbines directly to produce electricity and heat. And that we have overcome that obstacle, and I'll explain how we've done that. The importance and significance of this is that we would, as a consequence, generate energy more efficiently. Typically, we benefit from greater support, both in the UK and overseas. And as I mentioned, as an ACT, Advanced Conversion Technology, or Advanced Gasification Technology, we do and would continue to benefit from 2 ROCs in the UK. Plants are smaller scale for reasons I'll explain, and also the process offers greater versatility in terms of producing products which have a variety of end uses and not just power generation. So just to really highlight the energy conversion efficiency point I made, steam turbines generating electricity indirectly typically have a electrical conversion efficiency of between 18 and up to 25%, whilst using gas engines or turbines achieves significantly higher conversion efficiencies of between around 40 to 50%, especially when operated in combined cycle or with some energy recovery from steam in combination. But the ultimate goal really is to be able to generate electricity directly in fuel cells as fuel cell technology advances. as it will do certainly within the next 5-year horizon. And our process would produce a gas which could be used in fuel cells directly to generate electricity. So what is the process? Well, we have really taken conventional, proven, widely deployed technology and combined it in an innovative way. So we have taken gasification, in our case a fluid bed gasifier supplied by a US company with over 100 fluidized bed references operating around the world. That gasifier, after residual waste is pre-treated, so about 150,000 tons or so of residual MSW, municipal solid waste, or commercial industrial waste, having removed recyclates, shredded the material and dried the material to produce an RDF. We feed around 90,000 tons of RDF into the gasifier. This produces a crude or dirty syngas, as well as an ash. Typically the ash content is around 15%, so we might produce about 14,000 tons per year of ash. Both of those, both the syngas and the ash, are fed into a separate plasma converter, conventional plasma converter, as I said, treating about 14,000 tons per year, so it's therefore very much within the Tektronix reference plants, which typically operate on a much larger scale. And in the plasma converter, the ash is vitrified into a material which we have called plasma rock, which is classified by DEA as a product, and has a variety of end uses as a building material. It can be cast into slabs or tiles or into blocks. It can be spun, for instance, as an insulating material, as a rock wool substitute, and these are all applications that we are exploring. Additionally, the plasma, the functional benefits of the plasma, both the temperature but also the intense UV light within the vessel, have an excellent, extremely efficient at cracking the crude syngas, which contains long-chain hydrocarbons and aromatics, which would be harmful. Cracking those into constituent hydrogen and carbon monoxide, and that clean cracked syngas then goes into some secondary gas cleaning equipment, which removes any acid gas constituents in the syngas, so typically hydrogen chloride and hydrogen sulfide. Very conventional gas cleaning equipment before the clean syngas is then fed into the power island, so gas engines or a gas turbine, or looking ahead, fuel cells. This next slide really shows that functional benefits of the plasma, which I mentioned earlier. So the left-hand side of the slide shows sampling points within the gas exiting the gasifier here in Swindon, and you can see are pretty elevated levels of condensable tars and products which would normally have fed directly into a gas engine or turbine foul the engine very rapidly indeed. And on the right-hand side are samples taken for the same constituents. As you can see, are barely detectable levels of those long chain or aromatic hydrocarbons. I mentioned our suppliers, EPI, the US gasifier company, as well as Tektronix. Well, between them, they have some 180 references operating around the world, about 100 for EPI and about 80 or so for Tektronix, in a variety of applications and treating a very wide variety of feedstocks. It's important, in our view, that what is left in terms of residual waste is used to generate electricity and heat energy as efficiently as possible. And this slide just really, it isn't to any scale, but just, highlights the point that we really should be looking towards the most energy efficient forms of power generation from the resource material that is left after recyclate extraction, and the generation of electricity directly in engines and turbines, as I've said, is certainly the most efficient approach, with clearly landfill, to the extent that there is landfill gas extraction, being the least efficient and least desirable. Just to, I think, on a single slide to summarise the distinctions and differences between our process and typical energy from waste processes, conventional energy from waste processes. So with the same input material, taking 150,000 tonnes of residual unsorted waste, an incinerator would typically, numbers vary, but typically generate in the region of 10 megawatts or so, and produce about 20% or so of ash. So that would be 30,000 tonnes a year of material requiring treatment and disposal. Contrast that really with the same 150,000 tonnes of residual waste entering our process. We would extract some 40,000 tonnes per year or so of recyclates, which would be the metals, glass and dense plastics, which we remove at the front end, doesn't even enter the process. And then the plasma rock, the material we produce at the back end, which in itself is a recyclate with a variety of end uses. And then obviously the point which I've made, I think quite strongly already, that the energy efficiency in terms of what's left, the use of the fuel being significantly greater from our process, so generating in the order of, it depends exactly on the obviously the material entering, but in the order of 17 or so megawatts of power. So really, just to summarise the USPs for our process, obviously resource optimization being key, both the recovery of recyclates, the production of recyclates of products, and the high net electrical efficiency. We really embrace also the shift to zero waste, in that we achieve almost complete landfill diversion. We don't have a residual ash. We produce plasma rock, which is a product and not a waste, and for which there are a variety of end uses. The process is proven. The equipment is in operation globally in many references. We have a plant here in Swindon which has been operating since 2008, and the process has been validated and undergone technical due diligence by a large number of advisors and of contractors who have agreed to deploy our technology on a turnkey basis. We also, last but by no means least, offer a low impact solution. What do I mean by that? Well, we don't use air in our process. We don't have an inert nitrogen loading throughout our process. This means we use oxygen and steam, and this means that the process is very small scale indeed. So typically it would fit into an standard industrial warehouse of about 15 meters in height, with a footprint, including the front end, of about 1.5 football pitches, and the stack, subject to local air dispersion modelling, of course, is typically about 10 meters above the roof height, so about 25 meters in total in height. This allows us to locate closer to the waste arisings, to centres of population, reducing therefore the negative environmental impact of transporting waste long distances, but also, of course, avoiding the cost of doing so. And as a result of being able to locate closer to population centres, we maximise the potential for heat recovery. for operating in CHP, and many of our projects that we're developing in the UK do have CHP potential. So that I think is a very important point indeed. So those are really the summary of the benefits of our process, and I really just wanted to open it up to questions, Maxine. Thank you very much for listening.
Okay, that's great. Thanks a lot for that, Rolf. Before we open it up to questions, we're just going to look at the results of our second poll, which was, what is the biggest barrier to greater uptake of EFW technologies? We have a bit of a mixed bag here. 49% of you say it's investor confidence, 33% say it's community buy-in, and 18% say it's the planning process. Now that's quite interesting, isn't it? Obviously, investor confidence, you have the current economic climate, which is very challenging. So how do we get the funding that's required, Rolf, do you think, in these times at the moment?
Well, certainly we're seeing a lot of appetite from investors to enter the market. And I think, as I've set out previously, there is a critical requirement to obviously support the more advanced forms of generation, and to not make sudden changes to those support levels. But given that, we're seeing significant appetite, provided we can offer the kinds of investor returns that private money typically requires, and we're certainly, for our projects that we have in the pipeline, we're able to, under the current mechanisms, able to achieve those kinds of returns. So we are seeing a very strong interest in the EFW market in the UK, and in particular in supporting our projects.
Great, that certainly sounds encouraging. If I can just bring up the issue of community buy-in, it is quite a topical one always. I'd imagine there are communication issues out there when it comes to community consultation and getting councils, particularly the elected members, I think, on board, and also the public. People seem to understand incinerators. They're starting to understand things like anaerobic digestion. But terms like gasification and pyrolysis, they sound quite technical, I guess, to the layperson. So how do you start to educate people about these alternative technologies in a way that won't phase them, I guess, or turn them off?
I think certainly our experience of explaining the process to planners, to regulators, and to the public directly has been very positive. It does require a little bit of explaining. It isn't the conventional type of process, but our experience is that once the audience understands the benefits and the environmental credentials of the process, we get a very good reception indeed. I believe actually that communities tend to be supportive of waste management projects that deal with local waste in a benign manner, and which plough benefits back into the community. And I think that certainly the days of old that have actually gone, where people believe that waste just disappears and it's someone else's problem.
Okay. All right, great. We're going to go to questions now. We have had quite a few sent in. So if I'll take the first one. Does APP's technology work at similar levels of efficiency regardless of the characteristics of the waste input? And will it work similarly with... one moment, the question's just moved off my screen. Okay. Yes, will it work similarly with more moist waste commonly found in Asia?
Interesting. So certainly technically, the process is very versatile, can treat a very wide range of materials with differing CVs and with differing moisture content. Obviously, and some of the numbers I've presented, we have we have a certain design point from a engineering and from a business case point of view. But technically, certainly the process is very versatile. Obviously, what you put in affects what you get out. So, if you put in a low CV waste or a very wet waste, you're likely to get a lower CV gas coming out, and therefore it'll affect your performance of the power island in energy generation. So it's more a question that goes to the commercials and the economics of a project and of the plant rather than the process itself.
Okay, great. Someone's asked, I've heard that plasma gasification treats certain types of waste better than others, like hazardous waste. Can you advise on what waste streams it is best suited to?
Well, I'm glad someone's asked about plasma gasification, because we're at pains really to distinguish ourselves from plasma gasification. So what we don't do, although certainly looked at, is use plasma itself to gasify. I think certainly our experience of using plasma directly to create the syngas is that it has a relatively high parasitic load. We've therefore put the gasifier before it to reduce for the gasifier really to be the workhorse, and therefore reduce the parasitic energy requirements of the plasma. It's an optimum configuration. The gasifier does what it does best, and the plasma piece does what it does best, which is crack the syngas and vitrify the ash. So, but certainly the process I mentioned is very versatile. We have tested a great variety of feeds here in Swindon, a great variety of CV of materials. We've tested hazardous materials, auto shredder residue, contaminated wood, a huge array, and I think one of the benefits, is its versatility. But certainly plasma gasification and Tektronix experience of feeding waste directly into a plasma vessel, more focused on disposal and materials recovery than necessarily energy recovery. Has been again on an extremely wide range of materials.
Okay, great. And related to that, someone's just asked, can this process deal with tyre waste?
Yes, we have tested tyre crumb.
Okay, great. Another question, are there examples where the numbers stack up without fully utilising the heat generated, or is this an integral part of the design? How would the numbers stack up without utilising the heat element?
So we obviously would like, wherever possible, to use the heat. I think it clearly from an economic point of view, it improves the business case, but not dramatically. So it isn't required in order to get these plants financed. But it helps, and certainly there's currently a bit of uncertainty around exactly what the support might be for CHP, for operating in CHP mode. Perhaps the possibility of looking at a ROC upgrade of some sort, or the renewable heat incentive, so that they would, either of those would obviously help the economics too. But in the scheme of things, it's a relatively small part of the revenue stream. But we think important, because we should be really utilising the energy in the most efficient way possible.
Okay, great. Someone's asked, what is the potential for the hydrogen recovery for use as a vehicle fuel, given the inevitable rise in cost of oil?
That's a very good question. So some of the versatility that I mentioned at the outset, we produce a hydrogen-rich synthesis gas, which has a variety of applications, and we're exploring a great many. So whilst clearly direct power generation in a turbine or engine is what we're looking at for most of our projects currently in development, as fuel cells advance, we will move to fuel cells, and we'll be putting a fuel cell on the back end of our plant here in Swindon before too long. But the other uses are absolutely in the production of transport fuels, whether gas or liquids. So hydrogen, quite clearly, very, very high on our list of development priorities, but also the production of what's called synthetic natural gas, or bio-SNG, from our syngas. We can treat the syngas in a methanation process to produce synthetic natural gas to feed back into the gas grid. We're also working with partners on liquid fuels, so the use of the syngas as a constituent in liquid fuel generation.
Okay, great. Another question that's come in is how much of a market out there is there actually for the plasma rock, which is, I guess, the slag part? Is there any residual that goes to landfill, and how much?
We're very much exploring the market for the plasma rock, and we don't in our economic models, in our project models, ascribe any value necessarily to it. But we think it is, at the very least, it is a very good aggregate product. It doesn't leach, and it's undergone extensive leachate testing. It is harder than the naturally occurring granite, so it has some functional benefits. But it can be cast. We're looking in partnership in a consortium with others at developing higher value uses as a building material, tiles or slabs or blocks, for instance, or as I mentioned, I think rock wool substitute for insulation, which I think is quite a neat sort of closing of the circle. In terms of, we produce very, very little residue in the process itself. We have the only thing that we do produce, which Tektronix actually can treat in a separate plasma process, is gas cleaning residues or air pollution control residues for the removal of acid gas components from the syngas. It's less than 1% of the total feed into the process.
Okay, that's great. Someone has asked, it's quite interesting, price, particularly gate fees, are critical to sourcing waste streams in the UK. Can AP's technology compete on price with modern EFW facilities?
Yes. The simple answer. It is. It compares. It compares quite favourably with conventional, but at smaller scale. So that's an important point, is that we're seeking really to develop plants at the sort of 150,000 tonnes per year of residual waste, or 90,000 tonnes per year of RDF, which for an incinerator is relatively small. So it competes favourably in sort of capex per tonne terms, and at a smaller scale.
Okay, great. Someone's asked, do you receive tipping fees for gasifying the waste?
Absolutely. Obviously, it depends on the particular country. We do have inquiries from all over the world, but one of the pretty we have pretty strict sort of qualification criteria for taking those inquiries forward. But one of the essential parts really of the business case clearly is are the gate fees or tipping fees for taking the material in the first place. So we have four revenue streams really. One is the tipping fees, which are a big part of the whole economic model. Then the recycler revenues for the material that we take out. Then the power and heat revenues, and then depending on territory, a renewable support revenue, whether it's ROCs in the UK or green certificates in Belgium, or similar mechanisms around the world.
Okay, great. Another question, could you please explain more about the gasification unit? Does it need heat? If so, where does this heat come from?
It doesn't need external heat. It is a self-sustaining process. It uses a very small amount of the chemical energy in the feed to generate the heat to gasify the remainder of the feed.
Okay, great. This is an interesting one. Long term, do you think in the UK we should be looking to integrate small EFW facilities with new build housing estates to provide district heating, which would address the rising cost of energy for customers? And interestingly, I know Sainsbury's are actually looking at this very thing. Where they build a new store, they often have a requirement to build low-cost housing nearby that store. And all of their food waste now, they're looking to go through AD. So they're looking at the outputs of that AD process, maybe feeding into the district heating networks to provide power for those low-cost housing units. So what do you think on that, Rolf?
Well, I mean, it goes to the heart really of our design, philosophy and the whole process itself. So, absolutely, we offer a small scale solution which should be located close to centres of population, and wherever possible, we should be seeking to utilise the heat from the process. The concept is very much local waste for local power and heat, and whether it's new build, clearly we don't have a huge amount of district heating in this country, or whether it's existing industrial or domestic users of heat in schemes which do exist, and as I mentioned, most of our projects do involve some heat use. Contrast this with, say, the continent, which has very, established in many countries, Germany or Denmark, for instance, very established district heating networks, which are powered in many instances by conventional energy from waste.
Okay, great. A quick question: is it possible for you to forward the slides of the webinar onto anybody who's interested?
Yep, no problem at all.
Okay, great. I'd just like to raise something myself, actually. Your whole technology, what you've been talking about, is what I would call, I guess, is an emerging treatment technology. Naturally, there is caution out there about whether such technologies can be proven on a commercial scale, particularly in the UK. So can you offer any reassurance in that respect as to what your particular technology can achieve?
Sure. Well, I think I've set out hopefully sufficiently clearly that our process is nothing new. We're really combining two very well proven and conventional processes operating at commercial scale in a great number of applications around the world, and often at a significantly larger scale than we require for our own plants. So the innovation really has been in combining those existing technologies in a novel way. So I would characterise it as a new approach rather than a new technology. We have a plant here in Swindon, which certainly anyone is welcome to see, and we regularly have visitors and undertake detailed technical due diligence. It's been operating since 2008, and it's worked on a variety of different feeds, as I've mentioned, and TAs, technical advisors, have been quite a number have been through and have been satisfied, as well as engineering contractors themselves, EPC contractors with whom we're working, who will ultimately deliver our solution, deploy our solution, are equally satisfied on the process aspects.
Okay, great. And looking forward, when do you think the first wave of gas plasma commercial plants will start to come on board here?
Well, we're, as I mentioned, developing a significant number of projects, and our pipeline is growing very rapidly indeed. We expect our first projects to get away, hopefully in the UK, in the second half of next year, with quite a number to follow thereafter.
Great. And your plant down in Swindon, is that, if people are interested maybe to go to see that plant and the technology, is that something you can make available, like a trip down there?
Absolutely. We regularly host visits, and it operates typically 3 weeks a month. So, and more than happy to facilitate that. There is obviously, if someone wants to have direct contact, there is an email address I think at the bottom of the last slide of the presentation.
Okay, yeah, that's great. We're going to wrap it up now. That's all we have time for. There were still some outstanding questions. If your question hasn't been answered, please do email Rolf and APP directly with your points, and Rolf has said he will get back to anybody. And the email address should be there on the holding slide. Also, to let everybody know, this webinar will be recorded and will be available on the ED website as well. So I hope everybody found it an informative session. And on behalf of Rolf and myself, I would like to thank everybody for taking the time this morning to listen in. Goodbye.
Thank you.